In the year 1919, Eddington expedition, which was about to become famous later on, was carried out to see whether gravity can bend the path of light. A major test of Einstein's general relativity. By viewing a total solar eclipse, it was confirmed that the sun did change the path of starlight, as predicted by Albert Einstein. One of the greatest minds that world has ever seen before, making Einstein and his theory world famous. Now after a century, in this April 2019, scientists have again made history. All of them have once again pushed the limit of their astronomical knowledge to a step further to test Einstein's revolutionary theory. They did something so ambitious, Einstein and Eddington could never have imagined. They were all set to picture a black hole. The target seemed to be impossible until that. The story of black holes begins as a puzzle. In 1915, Carl Schwarzschild showed that the Einstein's then new general relativity theory equations predicted the existence of strange objects in nature, known as singularities. A bizarre place in nature. Inside them, where time stops and space becomes infinite. These things are too strange. At that time, when it was discovered, many physicists, including Einstein and the other pioneers of cosmology, considered them so strange to be worth seriously researching. Over 100 years of conquest, they are considered now as the most peculiar places of nature. Modern science showed that these singularities do exist in nature, termed as black holes. The term black was considered because of its gravitational pull that even light cannot escape.
A black hole is the most mysterious object in the universe. It's when matter gets to be in such a small space, and it's so dense that the force of gravity prevents even light from escaping. That's a one-way door from our universe.
We know they sit at the hearts of galaxies, and they drive how those galaxies grow and how those galaxies die. They swallow gas and stars up. There are also these incredibly enigmatic and mysterious objects that live at the boundary between our two great theories of physics, general relativity, which describes gravity, and quantum mechanics, which describes the smallest things in the world.
If you want to make a test of the fundamental theories of the universe, you want to go to the most extreme laboratories in the universe, and a black hole is that.
However, these extreme laboratories are not considered as a real one. As time goes, evidence piles up against the existence of black holes, and theories behind them become more established. Many scientists and many evidences were found, but none of them was directly viewed. However, because of their immense gravitational pull, even light cannot escape, and thus is an obstacle in directly viewing them. They are tiny, crushing huge amount of matter into a small point of darkness. Even as the existence of these strangest of objects became more widely accepted, seeing them directly remained an impossible dream. In fact, to reach the necessary resolution to see black hole directly, a single telescope would need to be the size of planet Earth. Obviously, it is impossible. So the only way out is to observe them indirectly. Although they are black, but some of the properties of black holes are directly detectable, such as extreme gravitational lensing, and the abnormal trajectories of interstellar bodies around these invisible black holes. These abnormal motions were the fundamental route to find a black hole until the beginning of the 21st century. But the extreme verification comes from black hole radiation. It is a kind of radiation coming out from these giant monsters. But how? How could something escape from them? After many years of research, many theories came to explain it, and one of the most acceptable theories is Hawking radiation and black hole thermodynamics, a theory encountered by Stephen Hawking. who showed that the black holes ain't so black. There are many controversies and doubts, but it is true that Stephen Hawking's work on black holes gives us a new way to understanding them. Even his work predicted the need of quantum gravity for the first time.
And so the idea is that out of nothing, if you like, a pair of particles is created and then exists for a short time and then annihilates. And that's happening throughout space. So it's happening there, and it's happening there, it's happening there.
This pair of particles is like yin and yang, night and day, opposites that would not exist without each other. One has positive mass, and the other has negative mass. But Hawking asked, what would happen if this pair of particles bumped up against a black hole? Hawking realized that the positive particle would have just enough energy to escape the black hole, but the particle with negative mass would fall in. And it would do something extraordinary to the black hole.
The particle that goes inside the black hole eventually decreases the mass of the black hole. It effectively has negative mass, but the particle that goes off to the distant observer is there observed as part of radiation.
Although we now understand why black holes have to give off thermal radiation, it came as a complete surprise at the time. At first, I thought I must have made a mistake.
But Hawking hadn't made a mistake. However, he discovered a new way to accomplish the dream to directly viewing them, that is, although black holes are black but their peripheries are not black. We can view the shadow of a black hole in the center of the glowing horizon. New theories were developed regarding them.
How do you take a picture of something that's shrouded by nature's ultimate cloaking device? What happens is the black hole's gravity is so intense that all the gas and dust that's attracted to it has to get into increasingly smaller and smaller volumes. And just as your hands heat up when you rub them together through friction, all that gas heats up to hundreds of billions of degrees. Everything around the black hole is ultraluminous. In fact, central black holes in the centers of galaxies can outshine all the starlight from all the stars in the entire galaxy. And that provides this three-dimensional flashlight around the geometry that's warped by the black hole itself. So as all that light is lensed around the black hole onto what we call the last photon orbit, it forms a ring. And that ring, the shape and size of it, fall right out from Einstein's field equations.
Astronomers researched for a decade and revealed that black holes have a large amount of matter around them. But the dream of getting more concrete evidence of these exotic objects is too tempting to be simply forgotten. This dream gave them a huge encouragement to go beyond in technology and knowledge, to get an image of the shadow of black hole.
We all understand from a mathematical point of view that black holes exist. But to actually see something is a very visceral experience, and I think important for science and also for us to believe in it.
But the resolution problem was not over yet. To overcome this, physicists used the concept of large-distance interferometry, one of the most amazing tools for astronomical observation of the century, which already grabbed some spectacular success in several ambitious astronomical projects, like LIGO. In the year 2008, EHT, the Event Horizon Telescope project, was launched to take a picture of black hole. by connecting 8 major telescopes throughout the world by large distance interferometry principle. Finally, the necessary resolution was achieved. The telescopes are very far away from each other. In April 5, 2017, EHT was first time focused on the chosen target, the Messier 87 galaxy, about 55 million light-years ahead, as a single telescope. They were all synchronized by atomic clocks. Observations showed that there is a black hole is present near the center of the galaxy. It is the largest known black hole, and isn't too far north or south in the sky. That's why it was chosen to get a better chance to picturing.
An array of telescopes that spread over the entire globe, acting together to synthesize an Earth-sized telescope. To be able to peer down to the black hole itself required doing this at higher frequencies than had ever been achieved before. This required recording petabytes of data.
Those recordings have to be brought back together to a central location where they're compared. We do all the timing afterwards in a supercomputer. And all that technology really has come about in the past 10 to 5 years or so.
So to have something here where we're able to see in a picture something that's been predicted now for about 100 years, and immediately connect it to a theory and immediately make constraints that no one's ever been able to make before. I mean, that is just, it's incredible.
And finally, after those sleepless nights of observation ended, a new phase was started. In order to define what they are seeing, scientists have to analyze about 350 terabytes of data per day. 2 computation centers, one in Europe and one in the US, combine those staggering quantity of data every day. Finally, after countless hours of work, an image is forming. So similar with the simulations. Although black holes themselves are completely dark, but they influence the path of photons traveling in their vicinity and leave a signature on the light from the accretion disk surrounding the black hole. A large disk of matter, gradually spiraling, due to large velocities and friction to each other, they are forming plasma. The path of light emitted by this glowing gas is influenced by the black hole, the light passing by it bent by the enormous gravity on the edges. But the light passes close is captured, never do escape. These effects from Earth, viewing by a radio telescope, manifest themselves as a shadow of the black hole. A dark centered glowing ring is appeared. In 10th April 2019 they released the results of the most ambitious project in the history of mankind. Released the picture of the shadow of something where time stopped. It's so amazing for scientists.
Something that reveals to you something that you didn't know before, and it scares you a little bit. An image of a black hole captures visually a one-way exit from our universe. We think about monsters, they're under our bed, or they're in caves, and when you see something like this, you realize that there are really monsters out there. The fact that we've captured this, I think, is not just for our team, but for all of humanity.
And we see that ring. We see the event horizon, and we see that shadow, that dark region. And you know immediately we're looking at an event horizon, at a black hole from all sides at once. This thing. We see at a region where time stops. This is a very different part of the universe that we're seeing for the very first time.
I mean, this is exactly what we have been looking for, but after 8 years and all that long process, a few weeks of imaging, and they showed us exactly what we wanted. I couldn't believe it.
I have to say it's taken on a new importance now, as we actually have images that look like the simulations. So it's an extraordinary confluence between theory and experiment, and it promises tremendous breakthroughs on the horizon.
Project that we've been working on for many, many years to take the first picture of a black hole, and we've done it.
legendary theory of Einstein and its concepts once again showed their accuracy just after 100 years, although it's a consequence, but it's a memorable moment. A dream comes true. The SCICOPATH is celebrating the 100th birthday of gravity and its event in the shadow of the black hole. Let's see what these telescopes and human conceptions helps to reveal this exotic objects. Now it's a way to test that how our universal laws behave in extreme space and time. But what is time?
Stubborn illusion.